lesson 10 activities. There are actually 2 activities here, and I'm not going to go over the first one in this video. Essentially, I would just be reading the answer key from the next page. So if you have any trouble with the activities on this page, just take a look at the answer key on the next page. And instead, I'm going to go through the interpreting graphs activity in this video. All right, so we're going to skip some parts of this problem. So I'm going to put a line through these parts right now. So the parts that we're skipping, I think, all have to do with the second derivative, which we're going to cover next class. So we will come back and answer these after we cover the second derivative. So in this picture, it's important to note that we are looking at the graph of y equals f of x. You're going to see this picture again in a coming class, and it will be exactly the same picture, but it will not represent y equals f. It might represent y equals f prime of x. But here it's y equals f of x. So where is f of x equal to 0? So we know that that's where the y is equal to 0, which is the x-intercepts. So I can see x-intercepts labeled right here. So I'm just going to grab those 4 letters. X equals A and C and F, and I think that's an I. A, C, F, and I. Looks good. Okay, where is f increasing? Use interval notation. Okay, so the function's increasing where it is going up. Assuming this graph continues forever this way, I would say it's increasing all the way forever up until the top part there, which is b. So I'm going to say minus infinity to b. It is totally okay with me if you put brackets here. Whether you say the function's increasing or not at the end point doesn't matter to me. There isn't really universal agreement on this in mathematical circles. I'll put parentheses. Union, because then it starts to decrease for a while, but then it increases again from D to F. Union, and then decreases here, but then increases starting at H and then going forever. So H to infinity. Even if you put brackets around each of these endpoints, you never put brackets around the infinities. Plus or minus infinity is always parentheses. Okay, H to infinity here. Okay, part C, where is f decreasing? So it's decreasing everywhere else. So we'll do this one quicker. From B to D, and then from F to H. And if you had put, I think that's it. If you had put brackets around all of the endpoints up here, you have to put brackets around all of them here. Just be consistent. Whichever one you choose is okay with me. Okay, we're skipping D and moving on to E. Identify the local extrema of F, and we're going to list the x coordinates of these things. So local extrema, just the points that are higher or lower than nearby points. So the tops and bottoms, peaks and valleys. So I see at B, you've got a max, and at D, you've got a min, and then another max at F, and then another min at H. And so I think that's it. So these are the local maxes here, and the local mins here. Part F, identify global extrema of F on the interval from C to J. All right, so C to J starts here, ends up here at this one. So it's just on this interval. So we're looking for the absolute highest point and absolute lowest point on that interval. So the absolute highest point on that interval is at the far right, that's at J. So the absolute max happens when X is J, and the absolute lowest point is at D. That point is slightly lower than the one at H. So the absolute min on that interval is at D. G, where is f prime positive? Use interval notation. So we're going to translate this. If f prime is positive, we know that that means that f, the original function, is increasing. And so now that we've translated that to the function that's pictured, it's easy to just look at the graph and answer the problem. We're just writing down where f is increasing. In fact, that's something we've already answered in part B. So I'm just going to say same as part B. That said, one subtle difference here. If you had chosen to put brackets, right, around all of these things here, then you would need to change that to open parentheses for this question, because this question is saying where's f prime positive, and you cannot make the case that up here at B, f prime is positive, because f prime is 0, and 0 is not positive or negative. So regardless of whether you did brackets or parentheses in parts B and C, you got to do parentheses in part G. So let's get rid of that stuff there. In fact, Yeah, I think that's fine. Okay, part H, but I will make a note here. Got to use open parentheses here. Okay, part H, where is f prime of x equal to 0? That is to say, where is this graph flat? And so it's flat up there at the top at B, and then at the bottom at D, and then another relative max at F, and then a relative min at H. Those are the only points where this thing is flat. Same answer as in part E for this problem. Next one, where is f prime increasing? Use interval notation. Okay, so this question's the trickiest one we faced so far. It really does have to do with the second derivative, which we just haven't talked about yet in class at this moment. But we can sort of get our answer as long as we're willing to do some analysis here. So I want to know stuff about f prime. So let's just think about f prime values here. So I'm just going to pick, you know what, why don't we just pick the dots that are already up here in this graph, all these black dots. And I'm going to draw a little tiny tangent line at each one because we are thinking about f prime, and we know that f prime is the slope of the tangent line. Okay, so roughly tangent lines like that. And so we're just going to think about the slopes of these tangent lines. I'm just going to make them up. So for example, maybe the slope of this one is 6, and up there it's a 0, and maybe that's like a -5, and there's a 0, and maybe that's a 1 and a 0, -1, 0, and this one's pretty big, 4 there, 6 there. So just looking at this collection of numbers, I'm going to read them left to right. 6, 0, -5, 0, 1, 0, -1, 0, 4, and 6. We're just thinking about when this collection of numbers, those are the f prime numbers, when that collection of numbers is increasing. Well, let's see. When we go from 6 to 0, is that increasing? No, that's decreasing. When we go from 0 to -5, is that increasing? No, that's decreasing still. But then when we go from -5 to 0, that one is increasing. And it's not just those two particular numbers. It's really that there's this in between here and here, there is a steepest downhill tangent line. It might be pretty close to this. If you called it up here, that would be okay. But once we get past that steepest downhill tangent line, you can see that these tangent lines get less and less steep, less and less negative in terms of their slope. And so that's going to form an increasing collection of numbers. Maybe its slope here is -4 and -3 and -2 and -1, and then we get to the 0. And so, but it doesn't stop increasing there. If you look at the next slope, maybe that's a 0.8, and then this one is a 1. But then we start to decrease again as we get up here to the top. So I would say that someplace between, I'm going to take all this stuff off of my picture here. Someplace between like C is where it starts to increase, the f prime, maybe over to here. Wherever the steepest uphill tangent line is in here someplace is where it stops increasing. So I guess I would say from C to E. Use interval notation. Okay, so increasing from C to E. It's okay with me if you put brackets around both of those. It's the same choice that you have as in part B of this question. Okay, and any other places where f prime is increasing? So let's see, as we look at tangent lines, starting from here, we go 1 to 0, that's decreasing. Then we go 0 to -1, that's still decreasing, so that's no good. We're looking for increasing spots here. Okay, let's put that back. But then we go from -1 to 0, that's increasing, and then 0 to 4 to 6, that's still increasing. So I think we could argue that the f prime starts increasing at G and then continues to increase forever. Okay, so from G to infinity, going forever. All right, and then where is f prime decreasing? Well, we're not going to go through this in the detail we just did, but I'm just going to say you can make the same kind of analysis, and we're just going to write the answer here. Minus infinity up to C, and then from E to G. And really, it's just like every place we did an answer for the for part I on this question. Just every other place. Okay, and then the local extrema of f prime. This is tricky as well, but we're just looking for values of f prime that are bigger than everybody nearby or smaller than everybody nearby. And I'm going to draw your attention to the important points that we just looked at here. C and E and G. Those are the important x values, the values where things changed for f prime, increasing or decreasing. So let's take a look at the slope at c. It's -5. Let's look at the slopes a little bit to the left of c. Maybe the slope here is like -2 and -1 and then 0. So -5 is smaller than any of the numbers on that side. And then the slopes again head towards 0 here. And so I think that c is actually a local min in terms of f prime. And let's take a look at the next one, which is e. So taking a look at e, the slope there is 1, and we claim that that was the steepest slope any place. And if you go a little bit to the right, the slope is not quite as steep. And if you go a little left, it's also not quite as steep. So I think 1 is the, or whatever the slope is at E is potentially the steepest slope anywhere. So that makes E a local maximum for F prime. And then finally for G, slope there was -1. If you're a little bit to the left, maybe it's like -0.5. If you're a little bit to the right, maybe it's -0.5. -1 is, or whatever the slope is right there at G, is probably the smallest slope anywhere nearby. So I think we're going to erase all of that mess in just a second, but let's write down, we've got mins at C and G. And then a max at E. Okay, so we're going to try to get rid of all of this stuff here. All right, I think that's good. Okay, I am also going to go over these last two questions real quick now, assuming that you have already learned about the second derivative. So if you haven't yet learned about the second derivative, maybe skip the next few minutes in this video. Just keep fast forwarding. I'm actually going to answer all the parts of this thing, this activity in this video. So if you don't yet know anything about the second derivative, maybe skip in this video down near the end. Just watch me do t and u. And then after you learn about the second derivative in a coming class, then you can come back to this video and watch the other parts. So coming back here to, where are we? I and j. So where is f prime increasing? So another way to think about this one. If f prime is increasing, that means that its derivative is positive. The derivative of this function right here must be positive. In the same way that we translated f increasing to f prime being positive, we're going to translate f prime increasing to its derivative being positive. So this really means where is the derivative of f prime positive, and the derivative of f prime, if we know about second derivatives, we can just say it is f double prime. And f double prime being positive, that means that f is concave up. And so armed with knowledge about the second derivative, this question becomes much easier than what we just finagled without referencing the second derivative. So coming up to the graph and just looking for places where the graph is concave up. So the graph starts off being concave down, down, down until we get to somewhere around C. And then it's concave up until we get to right around E, and then concave down until we get to roughly G, and then concave up the rest of the way. So those two orange things are where we're saying the graph is concave up, and therefore where f prime is increasing. So that is to say between C and E and between G and infinity. C to E and G to infinity, which of course is exactly what we said, but again, much easier when you know stuff about the second derivative. I would have thought that calculus would be easier when you know stuff. Okay, so we're not going to do the next part, but it's the same deal. To say that f prime is decreasing really means that f prime, its derivative, the derivative of f prime is negative, which really means f is concave down. And so if you check, you will see that check the graph, you'll see that f is concave down exactly on these intervals. And then finally here, the part K, the local extrema of f prime. So extrema of f prime are places where the derivative of f prime is 0. So one more translation here. where is something equal to 0? So the something is the derivative of what I've circled there in black. Where is the derivative of that circled function 0, but the derivative of that circled function is f double prime. The derivative of f prime is f double prime. And f double prime equal to 0 are places where concavity changes. Where is f double prime equal to 0 and where the concavity changes. So points of inflection are what we're after there. To be honest, the f double prime equal to 0 captures some things that potentially aren't local extrema. It's a detail that's probably not going to come up for us, but truth be told, this and this are not exactly identical. They're not exactly synonymous with each other, but for our purposes, it's good enough. This question is really just asking for the points of inflection. And again, if you take a look at the graph, you should hopefully discover that we've got points of inflection at C and G and E. Okay, so let's take a look at part L. We crossed it off for this lesson, but after we know second derivative stuff, we can do L. So where are the points of inflection of f prime? So I think we've just answered, wait a second. No, points of inflection of f prime, that's a problem. So points of inflection happen when the function's second derivative is 0. And the second derivative of that function is f triple prime. And looking at the graph of f, I would be hard-pressed to say anything conclusive about f triple prime. I can look at the graph of f, I can think about where it's increasing and decreasing, and that tells me stuff about its first derivative, f prime. And I can look at the graph of f, and I can talk about concavity, and that would give me information about its second derivative, f double prime, but I really can't look at the graph of f and say anything about 3 levels up, f triple prime. So this one here, I think our abbreviation is CBD for cannot be determined. That one cannot be determined. Okay, part M, where is f double prime equal to 0? So again, looking for points of inflection of the original function f, and it's the same C, G, and E. Okay, where is f double prime positive? So we're translating that into f being concave up. And so we just have to look at the graph to figure out that f is concave up between C and E, and then from G to infinity. C to E, and then G to infinity. Again, feel free to use close brackets on all of those, but not the infinity ever. F double prime negative really means f is concave down, which happens from minus infinity to C. You can take a look at the picture, union E to G. Okay, where is f double prime increasing? Let's translate that to say that any function is increasing means its derivative is positive. And its derivative, the derivative of f double prime, is f triple prime. And so I'm looking at the graph of f, and I'm trying to decide stuff about f triple prime, and any time you ask me to do that, I'm going to give you the answer cannot be determined. Where is f concave up? Okay, that one's easy. We've already answered that question right here. This is an easier version of that question, so I'll just copy that answer. C to E, and then G to infinity. And then where is f concave down? So I think we've answered that one in part O. So minus infinity to C, union E to G. Okay, S, where is f triple prime equal to 0? I don't know how many times I got to say this, but anytime you ask me to look at a graph and tell you about its third derivative, I'm going to tell you cannot be determined. Okay, T, what can you say about the sign of f of E? All right, f of E is a y value that is on the graph. F of E is this y value right here. It's whatever the y number is on the y-axis, the y-coordinate right there for that point, which happens to be the y-intercept. Is it positive? Is it negative? Is it 0? Well, it's negative. You're not supposed to be able to read what the number is, but just tell me that it's negative because you see that that point is below, physically below the x-axis. Okay, so f of e is a negative number. What about the sign of f prime of e? Okay, that's a different characteristic we're looking for. So f prime has to do with slope of a tangent line, and the tangent line here is some uphill positively sloped thing. So the value of f prime of e is a positive number because the function f is increasing right there. It's got an uphill tangent line, a positive slope. So with a lot of analysis and very little writing, it's a positive number. Okay, f double prime of e, that has to do with concavity. So again, focused on this point right here at E, is the graph concave up there or is the graph concave down there? Well, it's hard to say actually because it sure looks like point E is potentially a point of inflection. It's definitely, F is definitely concave up a little bit to the left and definitely concave down a little bit to the right. And so if E is a point of inflection, then f double prime of e is not positive or negative. F double prime of e is the spot where the f double primes, I should say e is the spot where the f double primes change sign from positive to negative. And so if indeed e is a point of inflection, then f double prime of e is 0. Okay, and then finally the sign of f triple prime of 0. I can't say anything about f triple primes on this page. So that's again a cannot be determined. Okay, and then finally, part X says sketch the graphs of f and f double prime on the grid above. Label your graphs as f prime or f double prime. All right, so this is tricky-ish, but let's see if we can get a very rough sketch going for these things. Okay, here we go. So we're going to graph f prime in red. Okay, so I like to start my graphs of f prime with the places where the tangent lines to f are horizontal. So at B, right, we've got this horizontal tangent line at D, at F, and at H. And so at each of those spots, the derivative we know is 0. And so we're plotting points of the form x comma slope of tangent line. And so at B, the slope of the tangent line is 0. At D, at F, and at H. And then we're just going to do very roughly to the left of B, the function f, which is pictured there, is increasing, which means that to the left of B, my f prime graph is supposed to be positive. But then to the right of B, right, f goes increasing and then it goes decreasing. And so that means that we're going to have some positively sloped things over here and some negatively sloped things here, which means we're going to have positive numbers here heading towards B, 0 at B, and then negative numbers. So we're just going to draw a very rough thing that's positive and then negative. And then the most negative it will get happens at the point of inflection of F, which I think we've already agreed is C. And so it's going to bottom out right there below C someplace. I don't know where it is. It's whatever the slope of the tangent line is at C. And then we got to turn around and we got to hit this x-intercept here. And then as we continue to the right here, we see this function is increasing until we get to f. So that means it is, the f prime values are all positive there. And so we're just going to do positive, positive, positive things, maxing out at the point of inflection between D and F, which is at E. So it maxes out someplace up there. And then it's got to turn around, still positive, but heading towards the 0 slope at F. Same deal here, going down, bottoming out at G. I can do a little better. Bottoming out someplace above or below G, and then continuing on forever. So that's a very rough sketch of f prime. Okay, and if that graph weren't cluttered enough, we're going to go ahead and draw our best guess for f double prime. And so here we're sketching points of the form x comma, and then I don't know, I mean, it's just f double prime. I don't really have a good way, like it's the concavity number. But we could think of this another way. You could think of this as being f prime, and I'll put that in parentheses, and then prime. The slopes of the red graph that's already up here. Slopes of the red graph that's up here. So we're not going to be too precise with this one. I'm just going to go for my points of inflection on the original f graph. So we already knew that the points of inflection were at C and E and G. And if you're at a point of inflection, then F double prime of that number is 0. And so at E, I have a second derivative value of 0. And at G, I have a second derivative value of 0. And at C, I have a second derivative value of 0. And the only other thing I'm going to look to capture here, I'm actually not doing this at all really. I'm just doing X value, and then is it concave up or concave down to give me a positive or a negative in the second spot. Okay, so again, focusing your attention on F, the original graph that was given. F is concave down here to here, which means that the second derivative at all those spots is negative, which means that my second derivative graph has got to be negative the whole time, and then heading up and hitting C. So something like that. And then going back to the original F graph, the F graph is concave up here to here. That means that my F double prime has to be positive in that whole interval, but it's got to come down and it's got to hit that x-intercept at E. And then again on the purple graph is concave down here to here. So that means I've got to be, my second derivative graph is negative that whole time, but it's got to come back up and hit at G. And then finally going back to purple for the last time, thank goodness, concave up here to here. That means that F double prime is positive the rest of the way. Something like that. Maybe not quite as abrupt a change. It just passes right through G and then goes positive forever. All right, so that's a very rough sketch for F prime and F double prime.